Hello everybody, welcome to this video which is about price elasticity of supply. Okay, so we've been talking about marginal cost curves in this unit. Important thing to notice is a marginal cost curve, as I'm sure we've talked about already, can also be considered as a supply curve, right? So blah, 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 blah. Here's the firm's marginal cost curve. If the price is $10, this tells us how many units the firm is willing to produce, aka supply, to the market. Let's say this was 7 units. So if the going price for this good is $10 per unit, this firm will supply 7 units. So marginal cost curve and supply curve, we will use those interchangeably. So just as we saw with demand, the amount that a firm is going to want to supply depends on what the market price is, and different firms can have different responsiveness to price changes. So let's look at an example of that. Okay, yeah, so here we have so what this diagram shows is we've got two firms, the red firm and the blue firm. This is the red firm's supply function. This is the blue firm's supply function. Initially, they are both, so so the market price is originally $5, and at $5, both firms are willing to supply 10 units. That's where at 10 units for both firms, that's where the price of $5 equals their marginal cost curve, or equals their marginal cost. And then for some reason, the price out in the market goes up to $12. We'll get into why market prices might change in the next unit, but let's just say this happens. As you can see, the red firm goes from being willing to produce 10 units to now being willing to produce 30 units. So their supply increases by 20 units. The blue firm at $12, they are willing to produce, it looks like maybe 17 units or something like that. So their supply has only increased by 7 units. So they only go up by 7. So we would say that the red firm, confusingly, I put the numbers in the opposite colors. Sorry about that. So this firm, the red firm, because their supply increased by 20 units, facing the same price change, we would say that that firm's supply is more elastic. So it was more responsive to changes in price. When they were able to get more money for their good on the market, they were able to expand production by more than the blue firm. So supply has elasticity just like demand does. It's still the same concept. We are measuring how responsive a firm's supply is to changes in price. When we were looking at the consumer side, we were looking at how responsive is a consumer's demand, or how many units they want to consume to changes in price. Now we're going to be looking at how responsive is the firm's output to changes in market price. So let's look at how to actually compute elasticity. It's the exact same formula and methods as we saw when we were doing elasticity of demand. So if we have a supply function, Q of S so it's a function of the market price. It's exactly the same as it was for the consumer. You take the derivative of the supply function with respect to the price, and then you multiply by P over Q. So literally the same formulas when we were doing price elasticity of demand. It's just now we're going to be taking the derivative of a supply function instead of a demand function. So there's an example on the next slide that we'll do. Okay, and so we've got a cute little supply function here, nice little quadratic. It's going to be super easy to take the derivative of. So remember the definition of elasticity. We're going to take the derivative of the supply function with respect to price, and then we're going to multiply it by P over Q. And in this problem, we're told to find the elasticity when market price is 5. Okay, so first things first, let's do the power rule here. Okay, so you get 2 times 1.5 P. So I did the power rule to the first term, brought down the 2, right here, and then multiply by 1.5 is there, reduce the exponent on P by 1. And now the second term minus P, I'll just get minus 1. Because I'm adding here, I can take the derivative of each term. This last term, the plus 2, that's just going to go to 0 because plus 2 is a constant. There was no P in that term. And I'm going to get 3P minus 1 is the derivative of this supply function. So then to get the elasticity of supply, I'm going to multiply this derivative of the supply function by P over Q. And just as before, instead of writing Q, I'm going to substitute in the actual demand function. All right. So this piece right here, this is the derivative of the demand function, and this piece is the P over Q from our little formula. We were asked to evaluate at a market price of 5, so I'm just going to plug in 5 for P at this point. So you get 3 times 5 minus 1 times 5 over 1.5 times 5 squared minus 5 plus 2. So that's in this parentheses here, you get 15 minus 1, which is 14 times 5 over, I'm going to need to break out a calculator here. 1.5 times 5 squared minus 5 plus 2. It's 34.5. So 14 times 5 divided by 34.5. You get 2.02898. 2.0. I'm going to put 3 because I'm running out of space here. And that is the answer. I think the next slide is just a printed out, nicely formatted solution to this problem. So hopefully I got it right, but you never know. Let's find out. Oh, Shazam. Good. I got it right. So this goes through the whole blah-de-blah that we just did on the previous slide. So, these problems, so as we saw in consumer demand and elasticity for consumer demand, it's the same rules about the value of the supply elasticity you get. If supply elasticity is greater than 1, we would call that supply relatively elastic because whatever percentage change in price there is, you're going to get a more than that percentage change in quantity supplied. If the elasticity of supply is in between 0 and 1, we would call that relatively inelastic because, again, like if you have a 10%, if the price goes up by 10%, the quantity supplied will go up, but by less than 10%. And then if supply elasticity is exactly 1, we call that unit elastic. One thing to note is when we were doing price elasticity of demand, we noticed that price elasticity of demand always has to be negative because when price goes up of a good, you will always demand less. That is the law of demand. That works reverse for supply. If I'm a producer and all of a sudden I can get $20 per unit for my good in the market instead of $10, I'm going to be like, yeah, I got to cash in on that, so I'm going to produce more. So from the supplier side, when price goes up, you will always want to supply more. So the supply elasticity, the price elasticity of supply will always be positive, as opposed to the price elasticity of demand, which is always negative. But that's pretty much it. It's mostly review. Same math. So just depending on the different supply function you get, you'll do the power rule. And we'll see some examples in the problem set. But it's pretty much the same as doing elasticity from that we did in the demand unit. So the second season of Stranger Things just came out, so I'm going to peace out so I can go start watching that. Can't believe it's already been out for 2 days and I haven't even started. I'm like way behind on my being geeky. So anyway, hope you all have a great day, and I will talk to you later. Thanks.